Hi, good morning, and welcome to the ZP Developer Zone. So we do this Developer Zone every Thursday at 8 a.m. London time, and I'll basically dive straight into it. So the first thing I want to just discuss is, obviously, I put this slide up every week, and we talk about, that we have lots of fairly good resources for people. We have our academy, our Developer Zone. We do this webinar every Thursday at 8 a.m. London time, and we also have collaborations, and there's also things like PhDs for offer, or internships for offer also as well, if you're a member of the ZP Developer Zone. I'm just going to sort of jump in and just give you a little bit. I put this slide up a couple of weeks ago. I was pretty pleased at the time. Make sure that I was pretty delighted at the time that we had made such a small set of electronics. So I did kind of mention that, and I just want to kind of give a little bit of an update on that now. We've actually been encapsulating into a tiny little capsule. The reason we're doing this is because this sensor is actually intended for implantation in veterinary type applications. So it's really quite nice because obviously it's tiny. It's implanted in veterinary applications. We're making, hey, cool. So I haven't seen, hi Dima. So we, as you know, we live stream, so it's nice to see some of the guys who have been around for quite a while with us. Dima has been a member of the ZP Academy since, I don't know, going back quite a long way, so super cool to see him. So we made this electronics. We've now encapsulated into a tiny capsule. And this really does talk to the power of modern engineering and also electrochemistry, that something as small as this, so this is the sort of size of it, these are the batteries, this is the telemetry, is so small, and you can implant it in regarding the use of our sensors. So yeah, I've just had a message from one of our guys that the webinar ended abruptly, which is a bit of a shame. So let's see if I can see if we can get back on. Hopefully back up. Yeah, hopefully back up. Let's really hope that we have actually got back up. Let's hope that's happening. So can anyone chat to me? Right. So we're just trying to figure out. Yeah. Right, okay, so I think I've now figured out that we are back online. My apologies for that. Right, let's start again. All right, so sorry, but back. So what's happening is we have these forum questions every week, and we try to answer them. So we've had many about the screen printed electrodes, and we've had one about PCB electrodes. So hopefully now you guys are following along okay. So one of the questions that's coming from the forum is it's a slightly sort of I wouldn't say controversial, but they were kind of asking, well, why is your product, or why is your screen printed electrode the best? Now, I'm not going to answer the question, why is ours the best, because, I really want to, sort of broaden the question and say, what's wrong with screen printed electrodes? Screen printed electrodes have been around for quite a while, but people have problems with them. Hopefully, and I know that Ali, who's a member of the ZP Developer Zone, he's also very knowledgeable on this subject. So let me just kind of dive into this a little bit. So the thing that makes Zimmer and Peacock and our screen printed electrodes very different is we are the biggest users of our screen printed electrodes in the world. So many people, let's say, manufacture screen printed electrodes, but actually they don't use those screen printed electrodes. And what I mean by that is they generally, we make a screen printed electrode because we want to make a glucose sensor from it, or we make a screen printed electrode because we want to make a lactate sensor from it, or we make a screen printed electrode because we want to make a COVID-19 sensor from it. So we really are the biggest consumers of our screen printed electrodes. Now, that means that we really need to get the quality high because we need to use those electrodes. It's a very different mindset that, we want quality electrodes because actually we want to use them. And something that makes us a little bit unusual at Zimmer & Peacock is when we give advice on screen printed electrodes, I know this sounds really strange, but we really don't, whether we sell one screen printed electrode in a month or a million screen printed electrodes in a month, it doesn't affect, the financial status of Zimmer & Peacock that much. And that means that really, we make these screen printed electrodes and we provide them almost as a service to the kind of academic community and the startup community, but we don't need to make our living from it. So that means that when we give advice about screen printed electrodes, it's not from a position that we need to sell that screen printed electrode. We get a lot of inquiries, for example, about graphene, screen printed electrodes. And I say to people, yeah, you can have a graphene screen printed electrode from Zimmer & Peacock, but honestly, it doesn't. Once you've made an ink from graphene and you screen printed it, it's really just become graphite, and you might as well just be using a normal carbon graphite electrode. So the advice from Zimmer & Peacock is based on the fact that, we don't need to sell those electrodes in order to be a profitable company. So the advice is very, I would say, unbiased in that respect. So Zimmer & Peacock, we're different as a screen printing company because actually we're not a screen printing company, we're much more, but we're different because we use the products an awful lot and ourselves, so we want to make them good. And we sort of sell them as a service to the community rather than as a necessity to the business. So we have a different motivation. Now, one of the problems with screen printed electrodes is, this is a sort of typical R&D screen printed electrode. It's fairly big. Now, this is one of our value screen printed electrodes. One of our value screen printed electrodes. I'm just going to sort of put them for comparison. And our screen printed electrode is smaller. And this is because if you look, and I'll just make that point on the slides as well. So this is fairly big. We also used to make slightly larger electrodes. But of course, when we looked at the economics of this, we realized, we have quite a strong background in commercial sensors. So this is a commercial glucose sensor. So if I just sort of hold a commercial glucose sensor up next to, look how small it is compared to that guy there. Now, the reason it's smaller like that is because if you're working in electrochemistry, then sort of by definition, you want to go to market often. You want to make a product that's commercially viable. If you make it on a screen printed electrode that is too big, you can never get the economics. You can never get the economics of the sensor. It's too big. You're using too much material. You can't shrink it down well enough to actually get an economic sensor. Now I'll show you an extreme case. This is an extreme case of a screen printed electrode where it's just too large. So we do get inquiries where people say, "Oh, I want this size," but it's so large that it's going to be very hard to be able to make this guy in an economic way. So our value electrodes are the right dimension to allow them to be manufactured at scale and to be at the right cost. So the size is important, and that's why we make ours the size they are. So size matters because if the electrode is too big, if you're working on a R&D electrode that's just too big, when it comes to volume manufacturing later on, you're going to find that the thing that you developed upon was so big that you can never get the low cost out of it. Good. So you can never get the cost out of it. So our value electrodes are the right size to give you low cost at volume manufacturing. Now the next problem that's really overlooked by screen printed electrode manufacturers is actually microfluidics. So on the ZP website, I know I've said this before, but we really think about how the sample comes to the sensor. And in fact, I've got an example here of a screen printed electrode with microfluidics on it. These microfluidics allow the sample to be capillary filled or wicked onto the sensor. And so our value and our hypervalue electrodes, we actually obviously think about this drawing of the sample onto the sensor, and we actually do kits on our website that allow people to get the screen printed electrodes, functionalize the electrode in what way they want, that's their kind of chemistry, and then to actually put the microfluidic down on top. So that's why we recommend our value screen printed electrodes as opposed to, let's say, our normal electrodes, because we don't want to recommend our, let's say, normal electrodes because they're bigger, they're therefore going to be more expensive to manufacture when you go to market, and we know that actually they don't work well with microfluidics. Microfluidics, you need a smaller electrode so that you can end up having a smaller volume to actually work the electrodes. So our value electrodes then work with our capillary technologies, and our capillary technologies are a little bit broader than that, because if you're a member of the ZP Developer Zone, you'll find that there's a store button, and under that store button you're going to find some 3D printable files. So our value electrodes, the second problem that our value electrodes solve is that actually we allow people to download STL files and 3D print their own microfluidics. Now, if you remember the Developer Zone, those files are actually for free as well. So the first problem with screen printed electrodes is they're all too big. They can't be therefore made at low cost if you try to commercialize it. The second problem is nobody's thinking about the microfluidics with a lot of screen printed electrodes, but at ZP we do think about the microfluidics because we end up making things like this. This just happened to be on my desk. This is a full cartridge for obviously analyzing the breath. So it's a full thing. So we think about microfluidics because we understand that electrochemical sensors are really going to become biosensors, and biosensors are part of in vitro diagnostics. So second problem nobody thinks about with screen printed electrodes is microfluidics, but we do. There's a 3D printed version, or you can also get this laminated version. Now the next one is really, I've titled it wrong geometry. Everyone likes a circular electrode because you've got a circular electrode, you can just pipette on top of it, samples, the solution spreads out, and you can functionalize your electrode accordingly. So we have a new page on our website, and I'll put a link in a minute, because on that new page you're actually going to find that under our value electrodes we do have circular electrodes. So if somebody's really committed that they want a circular electrode just because they can then easily pipette on top of it, we do have circular, let's say, electrodes in our value range. And this is actually a new page. It's been quite hard to find, so I'll have to put a link under the video afterwards. But we know why people like circular electrodes, such as this electrode. They love it because actually they can pipette on top of it quite easily. This one's another example, that people like because they can sort of pipette easily on top of it. But we actually do have circular electrodes in our value range, and you can find them on a page. But I just want to kind of go on a little bit now that I'm sort of saying that what's wrong with a lot of screen printed electrodes is they're the wrong geometry. Now what I mean by that is, and as I say, you can get these circular electrodes from Zimmer and Peacock, and you can pipette on those. If you do get the circular electrodes, I would recommend getting one of our connectors, because when you look at the geometry, you might want to swap over the reference and counter, because when I look at this is the working electrode. If you put this into a palm sense potentiostat, that would make that the reference electrode, and that would make that the counter electrode. But you'd actually want to reverse it, I would suggest. So it's better to use a connector like this, where you can put in 3mm banana plugs. So it's a slight divergence, but I want to say that fundamentally people like circular electrodes, and we understand that because they can pipette on top of it. Then in that case, we do have some circular value electrodes, and you can use those. But in that case, I would use them with a connector, and I'll have to put some links to that connector, I think, as well. Now, the right geometry for us is actually, this is one of our value electrodes. The right geometry for us is perpendicular electrodes. And I know this makes us look very, very different from other manufacturers on the market. But the reason that this perpendicular, I know Ali knows this, and Aftab, who's watching online as well, also knows this as well. And Shirley's also online as well. That great. Shirley says you can see you now. Thanks, Shirley. Shirley knows this as well. So a lot of you know this, but I'll just do it very quickly. The reason that we make perpendicular electrodes is because it's linked to the microfluidics point earlier on. You have a channel. Down that channel is going to come the solution, or the blood, for example. And as it comes down, it covers the electrodes in first electrode, second electrode, third electrode. So the blood comes down and starts covering up the electrodes. And at the end, it's covered all 3 electrodes, and the signal will suddenly jump up because you've actually completed the circuit. And so we make our electrodes parallel in that kind of line, because we're not thinking about your R&D, we're thinking about your product. And your product will have to have probably microfluidics involved. It'll probably have some sort of flow channel or capillary fill. And so the electrodes are pre-arranged thinking about the actual product. And that's why we make our electrodes rectangular and the way they're aligned. Because when I look at this microfluidic device, there's a little capillary channel in it, and the solution comes down, covers the electrodes in a sort of time manner. When you've got a circular electrode like this, and you were thinking, I'm going to have a capillary channel in it, it's going to be very messy. The reference electrode is off to the side, working electrodes in the middle, the counter electrodes kind of curl around the edge. So you don't get that clean series of events where one electrode gets covered and then another electrode gets covered and then another electrode gets covered. So that's why we make that strange geometry. Now we do understand that people like the circular electrode because they can pipette just on top of it. So what we do is we do this all the time in our lab. We just put 1 drop, 2 drops, 3 drops, just let the 3 drops coalesce, and you functionalized it. So why do people like these big circular electrodes? They like them because they're traditional. That kind of geometry's been around a long time, so they are traditional. They like it because they can pipette onto it, but they're too large to really be commercially viable. So take a look at a glucose sensor, which is the grandfather of biosensor and the grandfather of commercial biosensors. Take a look at one. They're quite small, they're too large. The traditional electrogeometry that people like in R&D is actually not that traditional. It's too large. It's got a nice electrode so you can pipette onto it, but we do a value electrode which is also circular, and we're also thinking about the microfluidics that will have to go with these sensors as well. Now I want to talk, the question was, why are you better than everyone else in the market? But I want to sort of talk about, we keep our quality high because we're the biggest consumers of our own screen printed electrodes. So I know I've said it before, but we want the quality high because we're trying to make, things like COVID-19 sensors out of these screen printed electrodes. So we need the quality high. Oh, and by the way, we then take a very small percentage of what we manufacture and put it on the market. So now what we're doing is, the reason our quality is high is because, first of all, we're doing wafer mapping. We will take something like 150 electrodes from the batch, and we will test them all by an electrochemical technique like cyclovoltammetry. And when I say test, this is straight from our lab. We're doing parallel testing here. We're fully gowned up. You know, it's not sloppy testing in a, you know, uncontrolled environment. Now, people like Shirley, who's online at the moment, people like Aftab, they're very aware of our Julie database. Julie exists because we've been doing wafer mapping and data collection for years and years. Now, Julie is this cloud database, but Julie exists because essentially when you look at Julie, it does a lot of, you put your electrochemical data in there, and you can put a lot of it in there, and it will do the, it will look at your batch of electrodes, and it will tell you your mean and your standard deviation. Why does that feature exist in Julie? Because we've been doing this wafer mapping for years, generating 150 cyclovoltammograms. Good luck manually processing that. So Julie exists because actually it started off as a quality tool at Zimmer & Peacock for this process of wafer mapping. So quality is high. Now, the thing that you will see companies out there that, you know, they're, you know, ISO 13485. Now, ISO 13485 means you are qualified to make medical devices. You've got to be a little bit careful with it because it means they have a quality system. It doesn't necessarily mean the product is quality enough for, you know, that people are still disappointed by the quality, but we are ISO 13485 as well, because it's essentially a minimum standard that we have to reach to be in this medical space. So our quality is high because we're the biggest consumers of our own electrodes. Our quality is high because we do so much testing of these electrodes before we ever ship them. You know, that's a provable fact because if you come to our labs, you know, you'll see these clean rooms where we're doing all this testing. And just out of interest, Julie exists because it's always been in our DNA to do all this testing. We needed a database that can really, really crunch this kind of data. Now, in terms of quality, I'm just going to make a point about quality. So this is one of our gold electrodes. So if somebody comes to me and says, I want a gold electrode, I tell them, go and use the gold 303. And this is some work that's come out of our lab, where we're testing we've made an immunosensor from it. So we've immobilized the antibody onto the gold electrode, and then we tested it at 5 nanograms per milliliter, 25 nanograms per milliliter, 50 nanograms per milliliter, and 75 nanograms per milliliter. When you look at that data, I mean, these are very low concentrations, and these sensors, we've actually handmade them. The same way that I told you earlier on, where we did 3 little drops next to each other in a line and just let the drops coalesce. So we've handmade these sensors. Could you imagine the quality of the electrode it would take underneath here to be able to make this kind of reproducible data? I mean, so I say to you that we have quality electrodes because we're the biggest consumer of our electrodes. I say we have quality data because we do all this testing, but this is actually then a real biosensor made on top of our gold electrodes. And I think you would actually find it very challenging to have data of this kind of consistency on a handmade sensor unless the electrode underneath was really of this quality. So, so yeah, Shirley just saying that, yeah, Julie definitely is a time-saving device. And Julie exists because we do, and as Seem say, perfect EIS graphs. They are perfect. Now, yeah, you know, and it's the gold electrode underneath that really does it. So our quality really is high. Why? Because we're doing it we're using those gold electrodes for ourselves, and we also put them on the website. There's a big, I call it kind of commoditization and cost. People think that a screen printed electrode is intrinsically, it should be a perfect product and low cost. So they want high quality and they want low cost. Now in life, high quality and low cost really don't go well together. Now, the only way you can get high quality and low cost is if you have high volume manufacturing. You know, so consumer items, I mean, I'll hold this one up. You know, it's a mouse from Apple. It's actually not. It's not low cost, but it is high quality. But they make it in high volume, and that's how they can sort of get it at I want to say reasonable price, but Apple is not reasonable. But it's the high volume manufacturing. Now, screen printed electrodes from many manufacturers, they're not making them in high volume. So they're not making high volume. They're actually only making 10,000 screen printed electrodes at a time. They're not high volume. Now at Zimmer & Peacock, we are genuinely if people come to us and say, can I have a gold electrode? I suggest them the Gold 303. Why? Because we make it in high volume, because we use it so much. So when people say, I want a gold electrode, but I want a very bespoke and commoditized, or not commoditized, but very tailored for myself electrode. The problem with that is it means it's low volume. And so you want a low volume, you only want, let's say, 10 sensors, 500 sensors, 3,000 sensors. That's so low volume that it's very hard to get the high quality, or it's impossible unless you charge a high cost for it. So we say to people, look, if you want high quality and low cost, come on to the electrodes that we use in high volume. So we suggest the Gold 303, and I often suggest the hyper value carbon electrode if it's on the carbon electrodes. We also do have platinum value electrodes as well. But we make these recommendations because we really believe in the quality, and we believe in the quality because we use them so much. And because we use them so much, we're always testing them, we're always making sure they're good, and the volumes are high. So everyone benefits by adopting those electrodes. Now, the other thing that's wrong with screen printed electrodes is people treat the screen printed electrode as if it's as if it's a sort of just a single component. But what I want to talk about here, I'm going to be quick a bit now because it is going on a little bit. But at Zimmer and Peacock, we see the screen printed electrode as part of a system. So if you're a academic developer or you're a startup company, and you should think of the screen printed electrode as part of the entire system. And I think we're the only company that really understands that the screen printed electrode is only part of the system. So we take a screen printed electrode, we might make some microfluidics on it, we put the sample on it, we sometimes put batch ID, we have meters that these screen printed electrodes or these biosensors go into. We make apps for these applications. That allows us to have Bluetooth connectivity between our system and our app. We have our Julie database, so we can push the data straight to the Julie database. We have APIs, we have user login. We then have all the data science that Julie allows for doing feature identification. Now the reason I bring this slide up is because I want to say that when we're talking about screen printed electrodes, we're not thinking about the screen printed electrode alone. We're thinking about it within the entire workflow of what it's going to take to get a sensor to the market. You've got the electrode, you have to build a assay upon it, you have to build electronics, you probably need connectivity to the cloud these days, you probably need to do data science on it. So, many companies that manufacture screen printed electrodes, they really don't have, the screen printed electrode is almost like 5% of the entire system. And because if you don't understand the other 95%, it's very hard to make recommendations on screen printed electrodes. So at Zimmer and Peacock, we recommend the size of our electrodes because we understand that it's got to be commercially viable. We recommend the geometry of our electrodes because we understand that there's probably going to be some microfluidics involved. And we recommend the Gold 303 or the hyper value electrodes because we know we make them in high volume. And so you can see that our recommendations are coming about because we actually understand the entire system. Hasim's just asking, can we get the access to the app of ZP Corona Check? They're not generally available to the public, but you and I will see each other on Monday if we can have a conversation about it then. So I'm going to skip this slide now, but I just want to kind of say that all the recommendations from Zimmer and Peacock about screen printed electrodes, because we understand the entire roadmap of making a product, because we do it. This is what we do. So I'm going to skip through quickly. Problem number 7 really is back to the size thing again, but this is just a nice illustration. This is one of our carbon value electrodes. Why should you use our carbon value electrode as opposed to our so why should you use something that looks like this as opposed to something that looks like this? And one of the answers is we always imagine that you're trying to make a sensor that's going to be used on real samples. So this is This is my blood. I prick my finger and I put 1 drop of blood on the sensor. And it tells you that we've designed the sensor so that in fact 1 drop of blood is enough to cover the sensor. So what's wrong with screen printed electrodes? I'm not sure how many manufacturers have really tried pricking their finger, getting 1 drop of blood and seeing if they can cover the electrode properly. At Zimmer & Peacock we do that. If you look at my career, the first job I ever had was actually making glucose strips. And so this idea about making sensors that can work with 1 drop of blood is kind of intrinsic in our DNA. So if you're ever wondering why our electrodes are smaller and the geometry that they are, we're also thinking about these sensors have to work with 1 drop of blood. Nobody wants to give 2 drops. Nobody wants to give 1 drop of blood, let alone 2 drops of blood. Nobody wants to have blood drawn using a syringe. And so our electrodes are designed to make sure they can work with 1 drop of blood. Right, the last thing now I think we're getting close to is support. There are a few companies who truly understand screen printed electrodes and therefore how to support clients. So we have our academy, as you know. Yeah, Ali asked, could you please also explain the sampling plan you follow for the inspection of manufactured SPEs? All right, I'll answer that question. But in terms of support, we have the ZP Academy. Thank you for sticking with me today, guys. I know that was a really bad internet breakdown in the middle of it, but we do have our developer zone, which is part of our support. And I think, what do our collaborators say about us? So this was put up on LinkedIn by one of the ZP Developer Zone members, a group called UpSense, and they were very complimentary because they come to the Developer Zone and they sort of commented that we help people with the design of their system, and also we understand, because we understand this technology very deeply. I think we're sometimes able to explain it, because if you understand it, you can probably explain it, and if you can't explain it, it's probably because you can't understand it. So that it does make a sort of a difference. Now Ali was asking, how do we decide upon the sampling for our SPEs? So when we're manufacturing SPEs, essentially we're producing, there's the beginning of the run and then we have the end of the run. So we're printing. So we take what we call a sheet from the beginning, the middle and the end. So we basically sample as a function of time through that manufacturing. So that's how we do it. And at each of those sample points, we're not testing 1, we're testing at least 50. So that's where I got that kind of number of 150 from earlier on. Right, I'm going to wrap up in a minute, but we did have a question that came in from about PCB electrodes. So I just want to comment on PCB. So on Zimmer & Peacock, we do have some PCB electrodes on the website. Everyone thinks that PCBs is a really good idea for the manufacture of screen printed electrodes. Be really careful. This is data that we have on the ZP website where we took a PCB electrode and then we did some cyclovoltammetry on it, and during the cyclovoltammetry suddenly the current went really high. Poosh, current went super high, and what's happening there is when we visually inspected it afterwards, you got these little pitting, and it's basically corrosion. That when they make a PCB, they have a seed layer of some reactive metal. I mean, it can be all sorts of metals, nickel and chromium, and then they put gold on top of it. But that gold is often quite spongy and porous, and therefore liquid can get through. And so when you do a technique like cyclovoltammetry, you're applying energy to the electrode, and if just a little bit of liquid gets in there and touches the seed layer, which could be nickel or chromium, suddenly that starts corroding. The current jumps really high, and you've just got really a signal of corrosion. So PCBs, they've been around for years. People are trying to use them as biosensors. The company that's been most successful is GenMark DX. They got bought by Roche, but there's a real problem. This is our own data about corrosion. So I always ask people, before you dive into using PCBs, you can buy them off our website, by the way, but you do have to, I have to give you a warning message, about PCBs. My honest advice is, if you want to make a gold electrode, just get going on the assay using one of our Gold 303s, because we use them a lot. We know the quality. We know they don't have this underlying weakness in them. Yeah, so, you know, lift off of the gold, exactly. So here's some links, but yeah, now if you are interested in PCBs, I think the best place to go is Massier Sensors. Massier Sensors is a sister company of Zimmer and Peacock, and they're really putting some effort now into PCB electrodes. If you want to find a link to them, just look under the About section on our website and you'll find a link to them. If you do contact Massier Sensors, when you contact them, let them know that you saw a sort of video by Martin Peacock, so then they'll understand the context of why you're reaching out to them. Right, so PCBs, be careful. You can buy them off our website. I'm just warning you about some of the dangers of PCBs, and my honest advice is go for a gold 303 from Zimmer and Peacock. If you really want to go down the PCB route, then I think the company that's leading this is actually Massier Sensors, because they're founded by a guy he's an electrochemist, so he knows how these types of electrodes are meant to functionalize or meant to work. So in summary, apologies for the internet breakdown. I'm lucky that we've managed to carry on today. So thank you for coming to the ZB Developer Zone. Thank you for all those lists of questions. I went through about 8 problems I see with traditional screen printed carbon electrodes and traditional screen printed electrodes, and then try to show you why we have what we have is not by accident. It's because we really have a vision for the person getting to market. And so, we discussed that today, and we also discussed the PCB. So I shall wrap up now. I do appreciate you all attending. I do appreciate you sticking with us while I had that sort of 4-minute gap with the internet. But all right, thanks very much. Thank you, Shirley. Thank you, Ali. Thank you, Aftab. And I also saw, who did I see? I saw one of our original members. Hasim is online as well today. Philippe is here, and Philippe comes an awful lot. So, yeah, I appreciate... Oh, and yeah, and Dimar as well. So, cool. Thanks, guys. And put your questions up on the forum, and I shall speak to you all again soon. All right. Take care. Bye-bye.